A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
Beneath the waves, giants whisper in a code older than humanity itself.
We said, hi, 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 Next time you want to say, how are you?
For centuries, we thought their haunting songs were nothing more than echoes drifting through the ocean. Strange, beautiful, but meaningless. We were wrong. With artificial intelligence, scientists have finally cracked the first pieces of this hidden code. And what they discovered isn't just communication. It's a structured language, complex and alive, revealing intelligence we never imagined. The question is, what are the whales really saying? For as long as humans have sailed the seas, the ocean has been a place of mystery. A dark expanse filled with legends of sea serpents and monsters too strange to believe. Yet, one sound has always lingered in the memories of sailors: the eerie melodic calls of whales. They seemed like music from another world, drifting through the water like ghostly hymns. For centuries, we admired their beauty, but dismissed them as instinct, nothing more than nature's background noise. That illusion shattered in the 1970s, when researchers first recorded humpback whales in the wild. What they captured stunned the world. Not random groans, but intricate songs that shifted, repeated, and evolved. The discovery sparked a revolution. An album called Songs of the Humpback Whale was released to the public, and suddenly people saw whales not as resources to be hunted, but as creatures with voices worth saving. That single revelation helped ignite a global conservation movement, rescuing whales from the edge of extinction. But even then, the mystery remained. Were these haunting calls just mating songs? Or were we eavesdropping on something much deeper, a hidden language between giants? Scientists tried for decades to decode the puzzle, but the data was overwhelming and the tools too primitive. We could listen, but we could not understand. That is, until a new kind of intelligence entered the picture: artificial intelligence. For the first time in history, technology gave us the chance to see patterns no human ear could ever detect. Suddenly, those endless strings of clicks and whistles weren't just noise. They were words, sentences, conversations. And what those conversations revealed about whales would shake the very foundation of how we see life on Earth. But to uncover that, we need to go back to where the first clues appeared. By the late 19th century, the study of whales had grown, but progress was slow. Scientists with tape recorders and hydrophones gathered hours of sounds, carefully labeling them, searching for meaning. They debated theories. Maybe the songs were courtship rituals, or warnings, or calls for help. But every conclusion felt incomplete. The ocean was speaking, but its voice was locked behind a wall of complexity. The truth was simple. Human ears and human minds couldn't keep up. The sheer volume of sounds, millions of clicks, groans, and whistles, was impossible to catalog, let alone decode. To most researchers, the dream of truly understanding whales seemed out of reach. Then came a radical idea. An American marine biologist, Dr. David Gruber, began asking a question that sounded more like science fiction than science. What if the alien intelligence we've been searching for in the stars has been swimming alongside us all along? Gruber looked to a surprising source of inspiration: SETI, the search for extraterrestrial intelligence. For decades, astronomers had scanned the skies for signals, repeating patterns in the cosmic noise that might prove another civilization exists. Gruber wondered, what if whales are our extraterrestrials on Earth? Their brains are 6 times larger than ours. Their lives span generations, and their voices echo through the deep in ways no other species can match. That thought became the seed of something extraordinary. In 2020, with the backing of the TED Audacious Project and a team of linguists, AI experts, roboticists, and marine biologists, Gruber launched Project CETI, the Cetacean Translation Initiative. Its goal was audacious, almost unthinkable, not just to record whales, but to speak with them. But to attempt the impossible, they would need more than scientists. They would need a dream team. When Dr. David Gruber unveiled his vision, many thought it was too bold, too ambitious. How could humans ever hope to decode the voice of whales, let alone hold a conversation? But Gruber knew the key wasn't one brilliant scientist, it was many. He began assembling a coalition unlike anything marine biology had ever seen. Leading whale experts, computer scientists, linguists, roboticists, and AI pioneers came together with a single mission: unlock the code of whale communication. Each brought a piece of the puzzle. Alone, they would fail. Together, they had a chance. At the heart of this alliance was Dr. Shane Garrow, a marine biologist who had spent over a decade studying sperm whales in the waters of Dominica. He wasn't just an observer. He knew individual whales by name, had watched families grow, and could recognize their distinct voices. His long-term work provided the foundation that AI alone could never supply: context. Without him, the data would be empty. With him, it carried meaning. Then came the engineers. Specialists in natural language processing, the same kind of AI that powers human speech recognition, were tasked with training machines to detect patterns in whale clicks. Roboticists designed autonomous drones capable of trailing whales and placing non-invasive tags on their bodies, capturing not just sound, but movement, heart rate, and social interaction. It was a bold fusion of human passion and machine intelligence. Biologists brought the knowledge of whale behavior. Technologists brought the power to process billions of data points. Together, they formed Project CETI's Dream Team. But gathering a team was just the beginning. To decode the ocean's greatest mystery, they would need something the world had never built before: a vast underwater listening and recording studio. And it would rise from the depths off the coast of a tiny Caribbean island. Dominica, a small island in the Caribbean ringed by volcanic peaks and deep, plunging waters just off its coast. To most, it's a tropical paradise. To Project CETI, it was the perfect laboratory. The geography allowed sperm whales to swim close to shore, returning year after year, making it one of the few places on Earth where long-term whale families could be studied in detail. Here, the team built what seemed impossible: a 20-kilometer by 20-kilometer underwater listening and recording studio. The heart of this system was an array of hydrophones, specialized underwater microphones anchored to the ocean floor in a grid pattern. Unlike a single recorder that could only capture fragments, this network listened continuously, 24 hours a day, mapping the soundscape of the deep in 3 dimensions. Every click, every whistle, every pulse was tracked, pinpointed to the whale that made it. It was as if the ocean itself had been wired for sound, every wall lined with microphones. For the first time, scientists could follow conversations as they unfolded, not just isolated calls. But the hydrophones were only half the story. To understand not just what whales were saying, but why, Project CETI needed more. Roboticists deployed autonomous drones capable of shadowing whales and tagging them with non-invasive suction cup sensors. These tags recorded sound, body movement, depth, and even heartbeats. Combined with the hydrophone network, they provided context. Was a whale hunting, resting, playing, socializing with family? Together, this technology produced something researchers had never dreamed of. Not hours, but billions of vocalizations tied to real-life behavior. It was the foundation of the largest whale sound library in history. But raw sound alone meant nothing. To transform this ocean of noise into language, the team turned to their most powerful tool: artificial intelligence. And what it found hidden in the clicks would change everything we thought we knew about intelligence on Earth. For decades, whale research had been trapped in the same loop. Endless recordings, endless theories, but no clear answers. The songs and clicks were mesmerizing, but they remained a riddle written in sound. What Project CETI had that earlier generations didn't was a tool designed for patterns far beyond human senses: artificial intelligence. The first step was to take raw sound and make it visible. Every click, every burst of noise was transformed into a spectrogram, a kind of sound map, turning audio into pictures. To the human eye, these looked like colorful streaks and dots. To AI, they were patterns waiting to be decoded. The system was trained on millions of whale codas, the rapid bursts of clicks sperm whales use to communicate. Unlike humans who might hear only static, AI could sift through the noise, isolating sequences, rhythms, and subtle differences in tempo. This wasn't guesswork, it was statistical precision, analyzing data points no ear could ever catch. Soon, the algorithms began to recognize something extraordinary. The clicks weren't random, they followed rules. They repeated in structures. Some sequences varied slightly depending on the situation, almost like different tones or inflections in human speech. Tiny ornamentations, an extra click here or a pause there, shifted the meaning.
To scientists, this was the moment of revelation. The whales weren't just making sounds. They were speaking in a system that had structure, syntax, and variation, the building blocks of language. It was as if the Rosetta Stone of the ocean had been uncovered, one spectrogram at a time. And the deeper the AI dug, the more it revealed. This wasn't a simple code. It was a language woven with complexity that rivaled our own. But what were these giants actually saying? The answer would stun even the most optimistic researchers. What the AI uncovered next was more than a pattern. It was a system, a kind of alphabet carried not in letters, but in clicks. Sperm whales, it turned out, communicate with codas that function like phonetic units. A rhythm could mean one thing, but a slight change in tempo or the addition of a single click could shift the entire meaning. Scientists began noticing rules, much like grammar, that shaped how these codas were arranged. Imagine the difference between the words cat and cap. Just one letter changes, but the meaning is completely different. Whales were doing the same with sound, stretching rhythms, adding pauses, layering ornamentations at the start or end. A slow, steady sequence might signal one message. Speed it up, add an extra click, and it became something else entirely. This wasn't the simple survival code scientists once imagined. It wasn't just danger here or food there. The whale's communication carried nuance, emotional shading, social markers, and layers of identity. Some sequences even acted like accents, varying from one clan to another. The AI could tell which family group a whale belonged to simply by analyzing its speech pattern. This discovery forced a dramatic rethink. For centuries, humans clung to the belief that complex language was uniquely ours, the crown jewel of human intelligence. But here, in the deep, was evidence of another species building meaning from sound with rules as intricate as any spoken tongue. The ocean, it seemed, had been holding a conversation all along. We just never knew how to listen. And then came the most astonishing revelation of all. Whales weren't just sharing information, they were telling each other who they were. As the AI processed billions of codas, another layer of discovery emerged. These weren't just words in isolation. They carried identity. Different families of whales, called clans, each had their own distinct dialect. Just as people in New York speak differently than those in London, whale clans could be recognized instantly by their speech pattern. A single pattern of clicks might be universal, but the rhythm, the ornamentations, or the subtle pauses marked it as belonging to a particular lineage. This wasn't learned in a laboratory. It was culture, knowledge passed from one generation to the next, a living record of history encoded in sound. Young whales grew up listening, imitating, and eventually mastering the dialect of their family. To belong was to speak the language of your clan.
For Shane Jarrow, who had spent years among the whales of Dominica, this revelation felt personal. He had already noticed family groups that traveled together, hunted together, and cared for one another. Now the AI confirmed what he had long suspected. Their voices weren't random. They were signatures of belonging, a social glue as powerful as blood. Even more remarkable, the codas seemed to carry context. The same sound could mean something slightly different depending on the situation. A greeting, a warning, or a reassurance. Meaning wasn't fixed. It was relational. Just as human words take on new shades depending on tone and circumstance, whale language shifted with the moment. This discovery was a shock to human pride. For centuries, we believed culture and language set us apart. Yet here was proof that another species also carried tradition, identity, and even accents. The ocean was not just a wilderness, it was a society. And then, in 2023, the line between their world and ours blurred in a way no one expected.
For decades, the dream of talking with whales sounded like fantasy. Scientists could record, analyze, even imitate their clicks, but real dialogue? That was beyond reach. Until 2023. Off the coast of Dominica, a diver slipped into the water with a device unlike any other. An underwater speaker connected to a computer that could play back a carefully chosen whale coda. It wasn't random. It was a sequence the AI had identified as common among sperm whales, a kind of phrase repeated in social settings. The team held their breath. The diver activated the speaker. The sound pulsed into the water, echoing through the deep. For a few long seconds, nothing happened. Then, a reply. A whale in the distance responded with the exact same coda, matching the rhythm perfectly. It was no coincidence. This was call and response. For the first time in history, humans and whales had shared a deliberate, intentional exchange. Not a mimicry, not an accidental overlap, a back and forth. The moment sent shockwaves through the scientific community. The data confirmed it. Our translation had worked. The whales had listened and answered. It was only a single phrase, a tiny ripple in an ocean of unknown meaning. But to the team, it was monumental. If one word could be understood, then sentences, conversations, even stories might one day follow. The implications were staggering. Humanity had always assumed we were alone in possessing true language, alone in carrying meaning across generations. But here, beneath the waves, another intelligence had spoken back. And yet the triumph carried unease. If we could speak with whales, what should we say? Because bridging two worlds doesn't just open doors. It also raises questions we may not be ready to answer. The 2023 exchange proved it could be done. We could speak, and whales could answer. But with the triumph came an uncomfortable silence. What now? Science had crossed the line. For centuries, whales were hunted for oil, slaughtered for profit, and nearly driven to extinction. Now, after decades of conservation, we stood on the edge of something even more invasive, entering their culture, their language, their private world. Was it right? Some researchers raised alarms. Communication isn't neutral. A phrase played at the wrong moment could alter whale behavior, disrupt family bonds, or even shift the way clans pass down their culture. For species whose language is inherited like tradition, human interference could ripple through generations. Others saw opportunity. If whales could share their needs, we might finally understand the pressures they face. Noise pollution, dwindling food, changing seas. Conversations could become a lifeline, a bridge for conservation built not on sympathy, but on dialogue. For the first time, whales could be heard in their own voice. But deeper questions stirred. If another species has language, culture, and identity, do they also have rights? Should whales be treated as non-human persons with protections not just for their survival, but for their voices? The debate spilled into philosophy, ethics, even law. Was humanity prepared to recognize another intelligence as equal? And if so, what did that mean for how we see ourselves? Project CETI pressed forward, careful, cautious, aware of the stakes. Their mission wasn't just science anymore. It was a responsibility. to listen without drowning out the very voices they had struggled so hard to hear. And as the work continued, an even bigger question emerged. Could this breakthrough change not just our view of whales, but our search for life beyond Earth itself?